Good morning. This is your stat sensei, Mr. Spensei, and this is a warm up. And we are going to be conducting a hypothesis test. So take a look at this for a two sample proportion. So scenario, it's a fluid situation. A study was conducted to determine if taking vitamin C reduces the occurrence of the flu. The study was conducted using 808 students, volunteers who did not take a flu shot. The subjects were randomly assigned. Ooh, that's important, randomly assigned, because that's going to impact our conditions to one of two groups. A treatment group who received 1,000 milligrams of vitamin C, or a control group who received a placebo. So we have two groups. Either you got something or you got a placebo. And the placebo is flavored to taste like the vitamin C treatment. All participants were monitored to ensure that they adhered to their assigned treatment on a daily basis throughout the period of the study. At the end of the flu season, each of the subjects' medical record was reviewed by a physician to determine whether he or she had contracted the flu during the period of the study. The physician did not know which treatment each subject received. The results of the study are shown in the table below. Does the study provide convincing evidence that vitamin C reduces the proportion of people contracting the flu virus at the 3% level of significance? Well, right away, I'm going to start with the 3% significance level because that's easy. That's my alpha that I have. That just made life easier for that. So this table is tricky. So of those who got the placebo, and apparently 405 got the placebo, so N1 equals 405, and X1, 331 got the flu. All right, and so this is for the placebo. So that means P hat 1 equals 331 over 405. When we go to the vitamin C, we have 403 taking vitamin C, so N2 is 403, and X2 is 302. So 302 got the flu. And our P hat C, our P hat 2 is 302 over 403. So we have that information. So let's take a look at this. So I labeled P hat 1 as my placebo. And our hypothesis is, and it's always going to be very easy because it's no difference, P1 equals P2. The alternative hypothesis is more people with the placebo got the flu than those with the vitamin C. And we said this was the vitamin C group and this is the placebo group. And I'm labeling them that way right here because we're not going to define our parameters. Our formula for P hat C, because we're going to need that to do our conditions, and that's the primary part of what I'm trying to do today, is make sure that we get those conditions right, is X1 plus X2 over N1 plus N2. So plugging in, we're going to have P hat C equals 331 plus 302, and then 405 plus 403. So let's add that numerator up. 331 plus 302, and we ended up getting 633. And for the denominator, 405 plus 403 is 808. All right. And so 633 divided by 808. And we end up getting about 78% of them. So 0.7834. P hat C equals 0.7834. And we're going to need that for our conditions. All right. Our conditions. Well, what are they? The first one, well, and by the way, this is placebo. This is vitamin C. And this is going to be random assignment. And that was given. And that's true for here too. This is random assignment. And it is also given. So we can check those off. The next thing, we have two samples. So two independent samples. So we're good there. Then we have number 3, which is our n is less than 10%. Well, we'd have to do n is less than 10% when we're doing when we have random sampling, but we have random assignment. We have a simple random sample, we have to do n is less than 10%, but random assignment, we do not. So we do not need to do this. So we're moving on to number 4, which is our normality condition, which will be n1 p hat c, and then n1 times 1 minus p hat c. So in this case, we said that n1 was 405. So 405. And we said p hat c is 0.7834 times 0.7834. So 405 times 0.7834 equals 317. So about 317, and that's greater than 10. We're good to go with that. Then we go to 405 times 1 minus the 0.7834. And I don't even know what that is. So 405 parenthesis 1 minus 0.7834. And I get 87, about 88. Is approximately 88, and that's also greater than or equal to 10. I don't mind the rounding as long as we are greater than 10. If it's less than 10, then we got a problem. Don't round. All right. So N2 P hat C, and then N2 times 1 minus P hat C. And this is the same P hat C that we had before, but our sample size is slightly different. Our sample size for the vitamin C group is 403. So 403 times 0.7834, and then 403 times 1 minus 0.7834. And 403 times 0.7834 equals 315, almost 316. Is approximately 316, and that's greater than or equal to 10, so that's good. And then 403 parenthesis 1 minus 0.7834 close parenthesis is 87. And 87 is also greater than or equal to 10. So all of our conditions are met, so we're looking pretty good there. Then our formula, this is the formula for running the test, and it's Z equals P hat 1 minus P hat 2, and then we have the denominator, which is P hat C times 1 minus P hat C over N1 plus P hat C times 1 minus P hat C all over N2. So I need to plug in. Well, first off, I need to check something out. I don't have everything that I need. Well, we'll continue with what we have. This is a greater than symbol, so we want the probability that Z is greater than, and we'll do the denominator first because we know that information. So 0.7834. And 1 minus 0.7834 is 0.2166. over the sample size of 405. This will be over the sample size of 403, and the numerator is going to remain, this part will be the same. So this is 0.7834, and this part is 0.2166. Now, what we haven't done is we haven't figured out p hat 1 and p hat 2. So let's do that real quickly. P hat 1 we said was 331 divided by 405. We said that earlier on. It was this 331 divided by that 405. 331 divided by 405 gives us p hat 1. So 0.1872. 8172. So basically 81% got sick on the using the placebo. And then we had 302 over 403 with the vitamin C. So 302 divided by 403. And in this case, we had about 75% or 0.7493. So now we've plugged in our values. And that's what it should look like. All right, we're going to go ahead and run this test. And we're going to go stat test, drop down to number 6, which is 2 proportion Z test. And we're going to have to start plugging in our information. Well, we said that our X1 was 331. Our sample size was 405. That was for the placebo. For the vitamin C, we had 302 catch the flu out of the 403. Oops, 403. And then for our alternative, we had a greater than, so that's what we need, and we have that. We press calculate, and we get the probability that Z is greater than 2.342. So the probability that Z is greater than 2.3429 gives me a p-value of 0.0095. So 0.0095. Well, 95 is definitely less than 300. So our decision is to reject the null. All right, so the important part of this is we made the decision to reject the null, which says our null was that there was no different. Our alternative was that vitamin C reduced the flu. It looks like, based on our sample here, the vitamin C was successful in reducing the number of people who got the flu. All right, I hope that helps, and I hope to see you on the next one. Thank you for watching.